Hello everyone, this is Nick, and this video is an introduction into Causal Fusion. Causal Fusion is a powerful causal inference tool created by Professor Bareinboim and his team. As of September 2025, it doesn't have any official documentation, and today we are going to look into its basic functionality, how to use the buttons, how to create directed acyclic graphs, and so on. We are not doing any causal identification or estimation yet. The first thing you have to do is to go to causalfusion.net and sign up. Then you will have to wait until you get approved before you can log in. After you log in, you will see something like this. Note that I'm running it on Windows, and for the sake of demonstration, I highlighted the left mouse click with red and the right mouse click with green circles. So let's go to Help. Here we get a reference to a great paper of Bareinboim and Pearl, and I recommend that if you want to learn about advanced node types in DAGs, such as Transportability node and Selection Bias node. Also, this book appears to be a useful reference. I expect that its terminology is consistent with that of Causal Fusion. This book is available for free on causalai-book.net. Okay, let's go back. Information about the team. Documentation is technically absent, so let's figure out how to use it by doing. Your working space consists of projects, one or more projects, and here you can rename your project, duplicate it, download it as a text file, but this is actually a JSON file. And that's how you can share projects with someone else. And then in order to upload a respective JSON file, you use this button. To clear a project means to remove all of the graphs from it. However, it appears that in any case you are forced to have at least one project, and every project is forced to have at least one DAG, which is populated with this default DAG automatically. Then you can delete your project altogether, and you can switch among your projects by loading. Every graph has this pop-up menu where you can duplicate it, move it to another project, duplicate to another project, rename, and leave comments. Duplicating projects and DAGs is a useful functionality because I didn't manage to find the undo button in the menu. I tried using Ctrl-Z, sometimes it works, sometimes it doesn't, so duplicating your project or your graph before making modifications is very useful. And if you made some modifications and you don't like it altogether, then you can remove the whole DAG by using this button. One great feature of Fusion is a library that's populated with a number of pre-created DAGs from a number of books and papers, including such classics as the Book of Y, Causal Inference Primer, and Causality. Let's load an instrumental variable example from the Book of Y. I don't want to delve into theory, but it's worth noting that the node types as defined in the Causal Primer are not exactly the same as in Causal Fusion. In Causal Primer, the variables are classified as exogenous and endogenous. Those are the two main node types. In Causal Fusion, the two main node types are latent and non-latent. So in this example, latent variables are depicted as gray circles and non-latent variables as white circles. In terms of causal primer, UZ, UX, UY are exogenous, and Z, X, and Y are endogenous. U is probably endogenous, but it's not observed, and therefore in causal fusion, U is exactly the same type of node as UZ, UX, and UY. So I guess it's fair to say that every variable that's exogenous or unobserved has to be latent in causal fusion. And here I skipped through loading two more graphs from the library. The first one is from the book of Y, and here you can see an example of a special type of node called Transportability node. The other graph is from Bareinboim and Pearl 2016, and this is an example of selection bias node. Again, to learn about the special node types, I recommend Bareinboim and Pearl 2016. And also, if you search on YouTube, you can find some video presentations that are based on that paper. Let's look at this top left menu that starts with selection mode and ends with causal simulator. I'm not going to cover causal simulator and do calculus inspector because it's beyond the scope of this introductory video. The first two buttons, selection mode and fast mode, I didn't manage to figure out how they work and what effect they have. But the next 5 buttons allow you to create 5 different types of nodes, respectively. A regular observed node, latent node, selection bias node, transportability, and regime indicator node. There are 2 ways to create a node. The first way is to click on this top left menu and then place a cross where you want your node to be. As you can see, you get immediately this pop-up menu that allows you to specify shape, border, other formatting options. For the first 2 node types, regular observed node and latent node, you can also switch between the node types. And there is a delete node button. Another way, which is more convenient, is to either double-click on the canvas or single right-click on the canvas, and then you will see this pop-up menu that duplicates 8 buttons from the top left menu. Then you can select your node and specify all the options. To get the full set of possible modification options for the node, double left-click, and then you'll see 2 menus. One is this pop-up, and the other one appears in the middle, where you can specify some extra options, such as the font size. To a certain extent, these 2 options, these 2 menus duplicate one another, but there are some options here that are not present here and vice versa. To connect your nodes, there are 2 types of edges, a regular directed edge, and I'm not sure if this is going to work, because oftentimes instead of drawing an edge, it just moves the whole thing. Yeah, like this. So let's try it through the context menu. Right-click on the canvas, a directed edge. There. Since that worked, let's try another one. No. This may need some work. Okay, now it's fine. If two variables are connected by a bidirected edge, it only means that there is a hidden common cause or latent common cause. So for instance, if I try to connect z and x with a bidirected edge, the system will automatically add this latent variable that's a common cause for z and x. You can assign labels to edges. So this is a single left click and you just select an edge. But if you double left click, you can give it a label or delete it. The same effect is achieved if you do just a single right click. There is this pop-up menu where you can add a label, formatting options, there is a field for a comment, change the style, and so on. The next button in the top left menu is a text box. You can insert it any way you want. Again, here I'm using the right mouse click, another text label here. Now let's go to node highlighting. So here you enter one or more node names. I entered X, and you can highlight the structure. First of all, parents, then ancestors. See? Ancestors are highlighted in red by default, and parents in yellow. And you can also see all the nodes that share the C component with the node in question. Very nice. The last option to cover is the latent node mode. If you toggle it, all of the latent variables disappear from the canvas. And if two nodes have a latent common cause, that is shown by a bidirected dashed edge. Now let's look at the top right menu. There are a few buttons here, plus there is this hidden menu. The first button on the left is Save Graph. Saving means saving it online, so it's there if you log out and log in back. Then you can duplicate your graph as many times as you want. Another way to do it is by right-clicking the tab and using this option. Then you can clear it, delete all of the nodes, but the text labels are not deleted. Download the graph allows you to download it as a picture, and there are a few formats available here. I tried it and it has a small bug as of today. It saves the file without extension, but if you add the extension by hand, such as PDF or PNG, the file opens as expected. Now, there is also a way to download and share your DAG by downloading it not as a picture, but as a JSON file, so that you can upload it to your project or someone else's project. In order to do that, you have to go to Editor and use this button. It says that it saves it as a TXT, but in reality it's JSON. And to upload your graph from a JSON, you use this Upload button. The next button is Fit View. You can see for yourself what it does. Label outside nodes. Your nodes become tiny and labels are now outside. The next button is full screen, and you will see as I go full screen, this kebab menu will expand. Here it is. And this button allows you to adjust your grid size and whether you want the grid at all. Then in the kebab menu, fit all graphs is the same option as fit your current graph, only it applies to all the graphs in your project. Then zoom in and out. Apparently these two buttons duplicate this functionality here. The next two look like undo and redo buttons, but I already told you that I didn't manage to find an undo button explicitly. These buttons, they just rotate left or right. Then if you want to make your graph look more neat, you can snap all the nodes to the grid. The coarser your grid is, the more effect that option has. And finally, you can draw your graph in topological order. Roughly speaking, it means that in topological order, every cause is supposed to be depicted above its effects in the graph. And in particular, that's why the node y, the outcome, is the lowest here in topological order because it has no children. Let's look at the preferences or options. You will see a number of checkboxes here, and all of them are checked by default except for this one, show interventions with do expressions. If you want to reset options to default, use this button. So here you can see some general purpose options. For instance, the regular nodes are denoted with the letter V by default, and latent nodes are denoted by U with subscript. Then in aesthetics, you can see a bunch of formatting options for nodes, edges, canvas color, paths, depending on the type of the path, a few types of conditional independencies, and this is something we've seen before. It's for highlighting functionality where you highlight parents, ancestors, and C component members with different colors. Apparently you can change them here. In components, we see a bunch of advanced options. All of them are checked by default. I will show them just for the reference, but they are beyond the scope of our introductory tutorial. Very well, that's pretty much for our basic introduction. Thank you for watching. And if you are into causal inference, please connect with me on LinkedIn.